Welcome to Summarize Science, where we break down complex research for everyone. Today, we are looking at a paper that reveals a massive blind spot in how we protect our software. Most people assume that when programmers write code, automated tools check every line for security holes. The researchers behind this paper found that these tools have a major flaw. They usually only look at one update at a time. They call this per-commit analysis, and it is the industry standard for most software companies today. The paper introduces a new benchmark called CrossCommitVuln-Bench to study this exact problem. The core discovery is something called a cross-commit chain. Imagine a security vulnerability as a puzzle that is put together one piece at a time over several months. Commit might introduce a way for a user to enter data, which looks like a normal, harmless feature. Commit B might happen much later, adding a function that processes that data without realizing it is dangerous. In isolation, both changes look perfectly fine to an automated scanner. However, when they exist together, they create a dangerous path that hackers can exploit. The researchers manually studied 15 real-world examples of this happening in Python software. To test their theory, the researchers used popular security tools like SemGrep and Bandit on these vulnerabilities. The results were shocking. The tools only caught 13% of the vulnerabilities when looking at individual updates. Even when the tools were allowed to look at the entire finished codebase, they still missed 73% of the issues. The paper explains that these tools often fail because they do not understand custom wrappers or project-specific functions. Another issue is absent guard invisibility, where a tool cannot flag a missing security check if it does not know one is required. Some of these vulnerabilities were introduced across time spans as long as 1,342 days. This means a security hole could be slowly forming in a project for over 3 years without anyone noticing. Table 3 in the paper highlights how often these vulnerabilities were marked as missed by the standard tools. This data suggests that our current automated security guardrails are far less effective than we previously thought. The detection gap shows that many threats can only be caught if a tool understands the full history of the code. So, what does this mean for the future of our digital world? The researchers suggest that we need to move away from snapshot security and toward systems that maintain state across history. By releasing this dataset, they're giving other developers the tools to build better, smarter scanners. In the future, security software might behave more like a historian, remembering every change made over the years. To recap, we learned that most security tools are blind to threats that are split across multiple updates. We also saw that real-world vulnerabilities often take a long time to fully manifest. This research is a vital step toward creating a safer internet where gradual changes are no longer invisible to our defenses. Thanks for watching Summarize Science, and stay curious about the technology that runs our world.